everyone, welcome to Organ Analysis. So welcome to yet another video. Now in this video we are going to start the new series that is called the spectroscopy series. So this is the part 1 of your spectroscopy series. Now in this series we are just taking some few of questions from previous year CSIR-NET, GATE or IIT-JAM level examination, and with this we are going to introduce some important questions that may come in your upcoming CSIR-NET or GATE examinations, so that both are very much helpful for you guys. And in this video we are going to learn you that how we can solve the spectroscopic problem and how we can analyze the data that are given to the questions and how to eliminate the options to find out the correct structure, right? So first of all, I am just taking this question, and this question was came in CSIR-NET June 2016, and this was came for 4 marks, right? So this is for 4 marks. So the question says that the compound displays the following spectral data. The correct structure of the compound is IR value that is given to you, that is 1690. So 1690 centimeter inverse. So this 1690 values indicates a ketone. So we have to find so different, and in the options there are given types of ketones are given, and if you look upon the options, that these two are ketone and this option B and D are in an ester. So from the IR value we can easily eliminate the option B and option D. So we know the ester value, IR spectrum of the ester, that values near around 1735 to 1740 centimeter inverse, like this. So, and this IR value, the IR value that are given to the question, that is 1690 centimeter inverse. So this compound doesn't contain any ester group. So option B and option D you can easily eliminate from the value of IR spectrum. Now if we start with the 1H NMR spectrum data, then we have to find that the value that is given first, that is the 2.5 singlet, and this is for the 3 hydrogen. And see, to find out the actual structure, we need to know some important NMR data so that we can easily find out the actual structure. So if we have this kind of structure, that is the toluene. So if we have the toluene, so this proton, this toluene methyl proton shows the value, this 3 proton shows the 2.34. So there is point, so this is 2.34, right? But the question that is given to you, that is the 2.5. Now this 2.5, it can be your attached with your ketone or some kind of electronegative group. But if you find the option B and option D, there is a both methyl group is present. Here is your methyl group and here is your methyl group, but these methyl groups are shown the value around 2.34, but the values given to you, that is for the 2.5. So this option B you can easily and this way you can also eliminate the option B and D, right? So option B and D is completely incorrect. So now you have to find this value, that is second value that we have, the 3.8 singlet, that is for the 3 hydrogen. Now this value is quite important. These 3.8 values indicates the OCH3 proton. So if we have a compound along with this, if we have the OCH3 and these protons shows the values around 3.8 to 4 delta values. So in the compound that we have, we need to find out the OMe group is present, either is this compound present or not. So this compound present this OMe group, and this compounds also present this OMe group. Now what about this 2.5 value? Now we can easily predict this methyl group shows the, here is your CH3 group and here is your CH3 group. These three proton will show the values around 2.5. Now we have to find this, either it is the meta isomer or the para isomer. So you can you have to know the value that is the given, this 6.9 doublet, and that is for the 8 Hz, and this is your coupling constant, that is Z value, and here is your 7.8 for the doublet, and that is for 2 proton. So if you see okay, first of all we need to know the why these values are 6.9 and 7.8. If we have a compound like this, that is your simple benzene. Now this simple benzene proton shows the value around 7.26 ppm, right? Now if the compound contains an electron donating group, then the values goes to the upfield, that is if the compound contains an OMe group or like electron donating group like this. So we can generalize it electron, so it is not is electron donating group, the values are going to less than 7.26, right? So this is value is 7.26 less than. And if the compound contains electron donating group, sorry, electron withdrawing group, so these values that the compound shows the 1 each NMR proton which is beyond 7.26, that is a downfield from 7.26 value, right? So we need to find this whether this compound contains the electron donating group or this electron withdrawing group. In this compound contains both this group, that is this is your electron donating group and this is your electron withdrawing group, that is a ketone which is attached with this compound. Now these two values that indicate that is this coupling constant 8 Hz. So this 8 Hz coupling constant indicates the value that is this is your para substitution, and you can see over here that is your doublet, and here is also your doublet. But if you take this proton, you have this one proton will show a different value, this proton will show another different value. We can write this is your HA and this is your HB, and here is your another proton that will be your HC, and here is your HD. So both the proton values are different in all the cases, but you have given the 6.9 value for only for two hydrogen. So what will be your the hydrogen? So here is your one hydrogen and here is your another hydrogen, and here is your one hydrogen and here is your another hydrogen. Now these two hydrogen is attached with this electron withdrawing group, so it will show the values around 7.8 because it is higher from the 7.26, the general aromatic proton values. So these two proton will show this 7.8 value, and this also show the 7.8 value, and these two proton, so we can write this HA and this is your HB, and here is your HB. So this value shows the 6.9 and this is also shown your 6.9 value in 1H NMR spectrum, right? So see, this is how we can generally eliminate the options and we can find out the correct answer. Now we have to know that whether these values is satisfying this compound or not, these 13 CNMR values. Now we know this 197 value that is given first to you, that is 197, and this value shows for this ketone, that is this carbon, right? So this value shows the 197 ppm, and the next 165 and 130, and similarly this is going to form another part, and this 26 value is for this carbon only, one CH3, and you can easily find out, and this 56 value is for this OCH3 group. Here is your OCH3. So these groups, this carbon shows the 56 just because it is attached with this electronegative oxygen group, right? So this is how we can easily predict the answer, that is your correct option is your option A, right? So see, this is how we can generalize and we can do this final product. And one more thing is that you can see over here this proton, this IR value that is given to you 1690. So it is lesser than 1700 values. So it is 1700 lesser than 1700 just because of the it can go this conjugation. So that is why this 1690 values shows in this IR spectrum, right? So this is how we can solve this question. Now let's move on to the another question, and this is your a completely different question, and this question may come in your upcoming CSIR-NET or GATE examination, and this is very important question. Now this question I'm taking from the Claydon, right? So I'm taking this question from Claydon. You can find out this question in Claydon book. And see the question that they have given this kind of structure has five type of compound, and they have given first the O3. Now we need to know what is the rule of the O3. So if we take if we take any compound like this, here is your R1 R2 and here is your R3 and R4. And if we do ozonolysis on this compound, so this is a simple alkene, and if we do the ozonolysis, we know that it can form, here is your R1 and R2 double bond O, plus it can generate this one, that is your R3, R4. So similarly, if there is a compound that is given here, the CH2 unit. So after the ozonolysis, it will do this one, right? Now, see that after the ozonolysis, it can do after the ozonolysis, it can do this one. So then it will do this one, right? It can generate this product plus H2C double bond O. So this is your compound X. Now this question can be framed in another way. So we have to now see the question, that is the characteristics peak in the IR spectrum compound X and Y. So we have already found out the compound X, and X shows the IR spectrum, that is 1820 and 1830, and you can easily predict that these two ketones are quite similar, so it can show the values around 18 IR values around 1820 and 1830, and that is quite similar. Now let's see the Y. There is from X to Y, they are given the minus 30-degree temperature. Now this four-member ring is quite unstable, so that is why in this lower temperature it can remove one molecule of CO2. So it can remove one molecule of CO2, and finally it can generate this kind of CH2 double bond C. So this kind of ketene, right? Now this ketene, and we know this ketene generally shows values in higher stretching frequency, that is around 140. So it will show this carbon will show this stretching frequency in the IR spectrum, right? Now how this CO2 will remove from the system? Now this CO2 will remove from the system in this way. So it will remove one molecule of CO2 and it can generate this ketene. Now see, you can easily predict the answer. The X and Y will be your D. But if the question framed in different way, that if they give now if they ask the proton, that is 1H NMR proton value in this compound, or if the 1H NMR proton in this compound, then what will be your answer? Now if we take this compound, that is your starting material, that here is your C and here is your two different proton, right? And here is your two different proton. Now what will be the value of these two different proton? Now we know the alkene proton generally shows around values around 5 to 7 delta values, delta ppm. So these two values shows around 4.5, and this proton will show around 4.85. Now why this difference is going to take place in this case? It is just because this oxygen is placed over here, so that is why it will show, it is show some kind of downfield, that is 4.85. that is why the value is completely different, that is this is your 4.5 and here is your 4.85. But these two proton values are quite natural, that is it will show the values around 3.9 and it will show the doublet just because of this proton, right? Now so this is your 1H NMR proton value. So this is your 1H NMR value of the starting material. Now from this one, only there is two proton that is given. So these two proton shows around the value of 4.12. So this will show the error value of 4.12 ppm, and the delta values around the 160 just because of this ketone. So if they ask the 13 CNMR values, so 13 CNMR values of this carbon is around 160.3. Now what about this one and this ketene? Now this ketene, these two protons are quite similar, so that is why these two protons shows around 2.24 ppm in 1H NMR proton, and this delta value shows around 193. That is your 13C NMR, right? So this is your 13C NMR. So this is how the overall values of this compound, and this question is very much important for your upcoming CSIR-NET, or maybe it can come in your IIT-JAM level examination. So I hope this video is very much helpful for you and very much informative, and I have this you guys like this series, that is a spectroscopic series. So I will try to continue this series after onwards, and if you have any question, let me know in the comment section, and I will definitely try to answer all your questions, right? So that's it for this video, and thank you so much for watching.